Dear students, I hope all of you are fine and welcome to Dhaka Online School. I'm here again with your English version class. Today I will take class 8 science class. You can share this class with your friends as much as you can so that your friends can be benefited from this class as well. Let's start. So as I told you, I will take the science class of your class 8 and the chapter is also 8. And our learning outcomes of today's lecture will be, you will be able to explain about element and compound, and then symbol, formula and valency, and rules of writing formula of compound. What are you seeing in this picture? So here is the scientist. He is doing some experiment over here in this picture, isn't it? Well, very good. And also you can see a picture of a burning rod. So can you guess which chapter we are going to learn today? So this is chemical reaction. Well, different types of chemical reactions are going on around us every day, everywhere. Around us, different kinds of chemical reactions are happening. So you can see some pictures over here of chemical reactions. So some reactions are releasing energy, some of are creating new materials, and some of chemical reactions are helping us to cure diseases. Elements and compounds. You know, according to structure, chemists have divided all the substances of the world as elements and compound. So what is element? The substance or the thing that is made of one substance, that kind of substance we called element. And the thing that are made of more than one element, that kind of substances are called compounds. So, you know, example of elements that hydrogen, oxygen, calcium, iron, these are example of elements. How many elements are there in the world? Till now, there are 118 elements are discovered. You can see all the 118 elements in this periodic table. So, by this 118 elements we can get compound. So example of compounds are water, hydrogen chloride, methane and alcohol. Lots of compounds are there in the world. So what is symbol and formula? The short expression of the element is called symbol. So whenever we are expressing an element in a short form, that time we use symbol. Like by this H, we can understand this is the symbol of hydrogen. Here O, by this symbol we can understand this is oxygen. And Ca, by this symbol we can understand this is the symbol of calcium. Cl, this is the symbol of chlorine. And Na, this is the symbol of sodium. So what is formula? The short expression of molecule of compound is called formula. So in our previous slide we have seen whenever we are expressing an element in a short form we use symbol, and like that whenever we are expressing molecule of a compound in a short way, in a short form, then we called that short form is formula. So formula of water is H2O. Formula of hydrogen chloride is HCl. By this formula of H2 we can understand it is one molecule of hydrogen. I can show you our previous slide. Here the symbol of hydrogen, one atom. This is the this H means that one atom of hydrogen. And here you can see in this formula, that is H2, this formula means one molecule of hydrogen, and here O2, O2 means the one molecule of oxygen, and CH4, this is the formula of methane. H2SO4, this is the formula of sulfuric acid. So we use formula to express the molecule of compound in a short form. Well, you can see the formula of water, H2O, hydrochloric acid, hydrogen molecule, oxygen molecule, methane, and sulfuric acid. You can also see here I have written 2 over here as a subscript of H. Here also subscript of H, that is hydrogen, and here 2 subscript of O, and here also 4, here also 2 and 4. But I didn't write any number here in this hydrochloric acid. Why? So to write the formula of compound, we need to know about valency. So this is a very new term for you, I know. We will gradually learn about it today. Okay, so what is valency? So according to the number of valency of the element, elements form compounds by chemical bondage. So according to the valency of the elements form the compound when they are chemically bonding or making a chemical bond. That time the valency of the element, according to the valency of the elements form the compound. We can compare the valency of the elements with our hands. How? Let me explain it a little bit more. The elements having valency 1 means it has one hand. When we say element has valency 1, that means we can understand that the element has one hand. As I am saying you that we can compare the valency of elements with our hands. So when we say a element has valency 1, that means that element has one hand. If I say hydrogen and chlorine, both are one-handed elements. That means their valency is 1. So hydrogen has one hand, so valency of hydrogen is 1. Valency of chlorine is 1, that means chlorine has one hand. Here formula of hydrogen chloride, valency of hydrogen is 1 and the valency of chlorine is also 1. If we consider hydrogen has one hand and chlorine has one hand, they attached or linked with this one hand with each other and form a formula or form chemical bondage to make a compound. This compound is hydrogen chloride. How this chemical bondage occur? By this valency. So hydrogen has valency 1 and chlorine has also valency 1. So if we consider this valency 1 as hand, they are holding their hands each other and making a chemical bondage. By making this chemical bondage, we get a new compound from the element hydrogen and from the element chlorine. What is that compound? That compound is hydrogen chloride. Here, forming a compound by the element valency is a most important thing. Okay, now another example for formula of water. And here you can see valency of oxygen is 2. It means one atom of oxygen has 2 hands. Through these 2 hands, one atom of oxygen can be attached with 2 atoms of one-handed hydrogen. Hydrogen has one hand. That means hydrogen's valency is 1. We have seen this in our previous slide, that valency of hydrogen is 1. So one-handed hydrogen, that means valency of hydrogen is 1. And here you can see the valency of oxygen is 2. we can consider this valency as a hand. So oxygen has two hands. One atom of oxygen has two hands. With these two hands, oxygen is holding two hydrogen atoms. With these two hands of one atom of oxygen, this oxygen atom with these two hands holding two one-handed hydrogen atoms and making a chemical bondage and forming a new compound, that is water, H2O. The formula of water is H2O. You can see two hydrogen atom and one oxygen atom is attached here. And another example, that is formula of ammonia. Valency of nitrogen is 3. It means one atom of nitrogen has 3 hands. How many hands? 3 hands. Why we are considering nitrogen has 3 hands? Because the valency of nitrogen is 3. Through these 3 hands, one atom of nitrogen can be attached with 3 atoms of one-handed hydrogen. We know hydrogen valency is 1. So we consider that valency of hydrogen as one hand. That's why here we can say the one-handed hydrogen. Valency of nitrogen is, so we can consider the valency of nitrogen 3 as 3 hands. Here are 3 hands of nitrogen, or the valency of nitrogen is 3. And here one-handed hydrogen, that means hydrogen's valency is 1. And another atom of hydrogen, the valency of hydrogen is 1. Another atom of hydrogen. So these 3 hydrogen atoms are holded by the 3 hands of this nitrogen atom. These 3 hydrogen atoms are held by nitrogen atom by these 3 hands. Formula of the ammonia is NH3. Another example we can consider here, formula of methane. So valency of carbon is 4. So valency of carbon is 4. How many hands we can consider that carbon has? 4 hands, because valency of carbon is 4. Through these 4 hands, one atom of carbon can be attached with 4 atoms of one-handed hydrogen. You can see 4 hands of carbon. That means carbon's valency is 4. Here one-handed hydrogen, one atom of one-handed hydrogen, another atom and another atom. These 4 individual hydrogen atoms are held by 4 hands by this carbon atom. So these elements are making a chemical bondage by their valency. The formula of that compound methane is CH4. You can see the examples we have discussed. Hydrogen chloride. So valency of hydrogen is 1 and chlorine is also 1. Here oxygen is attached with 2 hydrogen atoms. So oxygen holds one-handed 2 hydrogen atoms. Here nitrogen holds 3 individual one-handed hydrogen atoms in ammonia. And in methane we can see carbon by its 4 hands, it's holding 4 individual one-handed hydrogen atoms. The valency of the element means the number of hydrogen atom attached to that element. As the definition of valency, we can say the valency of the element means the number of hydrogen atom attached to that element. Here you can see chlorine. How many hydrogen atoms are attached with chlorine? 1. Because chlorine has one hand. That's why he can hold only one hydrogen atom with its one hand. So valency of chlorine is 1. Here oxygen is holding 2 hydrogen atoms with its 2 hands. Valency of oxygen is 2. Here you can see nitrogen is holding 3 different hydrogen atoms with its 3 hands. That's why the valency of nitrogen is 3. Here you can see methane, carbon is holding 4 different hydrogen atoms with its 4 different hands. That's why the valency of carbon is 4. The valency of the elements means the number of hydrogen atoms attached to that element. At the time of formation of a compound, it is to be considered that all the hands or valency of an element are satisfied. Well, here is the table, the valency of some elements and radicals. In this table, you can see here non-metal, metal, radicals, valency 1, 2, 3, 4. So these are the elements, those have valency 1. Here are the radicals, these are not elements. I will explain what is radical a little bit later. So valency 2, here are the list of the valency 2, valency 3 and 4. You can see iron. Iron has valency 2 and iron has also valency 3 over here. And you can see lead. Lead has valency 2 and lead has also valency 4. So here sulfur is also valency 2 and sulfur is also have valency 4. So from this table we can understand that some of the elements has more than one valency. So some elements have valency of more than 1. So here are the example: sulfate, carbonate, nitrate, ammonium, etc. Group of atoms. These are called the group of atoms. They do not stay individually or independently in the environment normally. This type of group of atoms, those do not stay independently in the environment naturally, and they participate in compound formation like an individual atom. They act as an individual atom whenever they are forming or whenever they are taking part in the formation of a compound. This group of atoms is called radical. In the previous chart you can see here ammonium has a valency 1. So this radical will act as one atom when it is forming or it is taking part in the formation of a compound. And this carbonate has the valency 2. This sulfate has valency 2 also. Phosphate has valency 3. So this group of atoms that are that do not stay in the environment naturally independently, these kinds of and act as one atom in formation of a compound, these group of atoms are called radicals. Here are some rules to write the molecular formula. So what is formula? We know that whenever we are expressing compound in a short way, short form, and then we call it a formula. So there are some rules whenever we are writing a molecular formula. So formula number 1 is, if the valency of the element or radical is same, it is not necessary to write valency in the formula. I gave this example in our previous slide, that hydrogen chloride. I didn't write any number over here. Why? Because we know now that the valency of hydrogen is 1 and the valency of chlorine is also 1. So the valency of both elements are same, that is 1. That's why we didn't write the valency in the formula over here. This is said in this rule number 1, that is the valency of the element or radical is same. It is not necessary to write the valency in the formula. Only element and radical are to be written together. Here only we have written the we have written the symbol of the element in this formula of the compound. So as we have write hydrochloric acid here, HCl, that is hydrogen chloride. Same we can consider calcium oxide, that is CaO. Both calcium and oxygen has valency 2. Valency of calcium and oxygen is same here. That's why we didn't write the valency number here in the formula. Like hydrogen chloride and calcium oxide, ammonium chloride. So this is a radical. The ammonium valency of ammonium is 1, we have seen in the chart, and the valency of chlorine is 1. We didn't write the valency in this formula as well. Ammonium nitrate. Valency of ammonium, we know the valency of ammonium is 1, and the nitrate, valency of nitrate is also 1. That's why we didn't write the valency in this formula of ammonium chloride as well. Okay. Here is the rule number 2. If the valency of one element is any multiple of valency of another element, the valency of both elements is divided by that multiple. Then the divided result is exchanged and is written as suffix. I can explain it a little bit more. Carbon dioxide, you know the formula of carbon dioxide, CO2. Here valency of carbon is 4. You can see from the chart here, valency of carbon is 4. This chart is in your book also. We know the valency of carbon is 4 and the valency of oxygen is 2. Here you can see valency of carbon is 4 and the valency of oxygen is 2. Whenever we are forming the formula of the compound of molecule of carbon dioxide, we take C, the symbol of carbon, and we take O, the symbol of oxygen, and now we will take this 4, the valency of carbon, as the suffix of oxygen, and we will take this valency 2 of oxygen as the suffix of carbon over here. Here you can see C2O4, but our formula of carbon dioxide, we always write CO2. How do we get CO2 from C2O4? So here you can see 2 and 4. These 2 and 4, these two numbers is the multiple of 2. We can divide by this 2 by 2, and we can also divide this 4 by 2. After dividing this 2 by 2, we get 1, and after dividing this 4 by 2, we get 2. That's why we didn't write here any number, because 2 divided by 2 is 1. Here no number is written here. That means it is 1 and O2. How do we get this 2? By dividing 4 by 2. The result is 2. So that's the way we get the formula of carbon dioxide, CO2, using rule number 2. Okay, and then rule number 3 is, if the valency of both elements is different. In first rule, we have seen that if the valency of elements are same, and then we have seen if the valency of elements are different and multiples of any number. And here we can see if the valency of both elements is different but not any multiple. Like valency, this is an example, of A is X and the valency of B is Y. Then the formula of compound formed with A and B is AYBX. In our previous slide, you have seen the valency of carbon written as a suffix of oxygen, and the valency of oxygen is written as a suffix of carbon. And in that way, this formula is written AY and BX. So the valency of element A is written as the suffix of B, and the valency of element B is written at the suffix of A. If I take an example, ammonium oxide Al2O3. You can see aluminum oxide Al2O3. Here the valency of aluminum is 3 and the valency of oxygen is 2. So how we will form the formula of this compound aluminum oxide? Let's see. The valency of aluminum is 3. The valency of oxygen is 2. Here I am taking the symbol of aluminum Al, and I am also taking the symbol of oxygen O. Here now I will write 3, the valency of aluminum, as a suffix of oxygen, and here I will take the valency of oxygen as a suffix of aluminum. So here valency of oxygen is 2 and the valency of aluminum is 3. This 2 and 3 is not multiple of any numbers. That way we didn't divide this 2 and 3. We don't get an whole number by dividing this 2 and 3 with any number. So we will keep it this way. And thank you for your kind attention for our class. Stay tuned with Dhaka Online class. I hope you will be benefited by this class, and stay at home, study more. Thank you very much. See you in the next class. Bye.